Sometimes when I start recording these, I'm like, I should have music playing. Dun, 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 dun. Algebraic expressions and equations. All right, favorite topic because we are going to do language translations. We're going to do the language of English to the language of math. Yes, math is a language. And there are tricks and all kinds of strategies and tips you can use whenever you are translating from one language to another. Now, some of you even speak different languages, so you know that there's ways that you translate. So let's see about some other languages. Who can tell me what language this is? And I bet you could, of course, read this a lot better than I can because my Spanish isn't all that great. Oh, I give it away. It's Spanish. Man. Okay, let me try the next one. Okay. Guess what language this is? Uh, yeah, I don't know. It's Russian. Some interesting characters in there. Okay. Guess what language this is? Oh, I recognize one word. That is Finnish. Guess what language this is? All right, I have to admit I had a student write that for me, so I'm really hoping that is Korean and not. Okay, I'm pretty sure it is. We're good. What about this one? It is Vietnamese. Now, what I want you to know is that every one of these sentences say the exact same thing in these five different languages. And they all say, today is a beautiful day for math. Oh, isn't that nice? It's like we should have sunshines on this page or something. Hoy es un día bonito para matemáticas. Every one of these says today is a beautiful day for math. But when you translate from a language like English to a language like Finnish, well, let's just count it. Is this the word today is a beautiful day for well, I know that's the word math, so something didn't go. Is it word for word? What about, let's try Korean. Today, is that the whole word is, or is that is a beautiful day for? I have no idea. The thing is, when you translate from one language to another, it's not done word for word. It's done by meaning. All of these have to mean today is a beautiful day for math. So, that's the same thing when we translate from English to math. When we translate, it has to mean the same thing when we're done. So that's what we want to double check when we're done. So we're going to take verbal statements from English and write them into algebraic expressions, or we're going to do them in equations. But in order to translate from English to math, you have to understand that there are a lot of English words to represent very tiny math symbols. Let's take a look at this. Equal sign. I've got the word is, was, are, and equal. And if you watched the video that was in folder A, you saw those words there. So in math, we just go, hey, look at these two little lines. And in English, they're like, well, let's just do it this way. We've got all these varieties. This one just blows my mind. In math, we just use this. See why I like math? It's so straightforward. But in English, this symbol could be spelled as add, sum, increased by, more than, exceeds, total, plus, in all, gain, deposit, tax, in addition to, interest, markup. So when you're reading a story problem, all of those words could possibly mean writing that little symbol. Yeah, that makes it a little bit rough, especially when you're doing translations. And how about this little tiny symbol here? Means subtract, difference, decreased by, fewer, less than, minus, take away, withdraw, reduced by. I'm sure there's more, but in math we just use this little dash. In English, you have lots of options depending on what you're writing about. And how about, now I use the asterisk, but normally we use parentheses or a number next to a letter means to multiply or find the product. The word of, oh my gosh, in story problems, of is huge. Times, double, triple, twice. And lastly, we have the division bar, a dot bar dot. And we do write division a lot differently in algebra. We usually use just a bar with a number on top and a number on bottom. I think you're probably thinking, isn't that a fraction? Why, yes, a fraction is no more than an unfinished division problem. You are right. But in English, this could be represented as the words divide, quotient, per. Not like a kitty, no. Divided by, split into, fraction, ratio of, out of, like 25 out of 100. Goes into, how many times does 7 go into 56? Before you start translating English to math, you probably should know what the English words are. So I hope you wrote these down or you printed this page off. Either way works for me, or you already know them all. That's also an option there. Okay, so let's get started. We're going to translate the following algebraic expression. So we're going from English to math. Here's our first one. 17 take away 4 multiplied by a number. First things first, the numbers are the easy part. I got a 17 and I got a 4. So we're probably not going to worry about that too much. But let's look at some specific phrases. Let's start here. Take away. What does take away translate to? All right, keep going along. What does multiplied by translate to? And what about this phrase, a number? What are we going to put in there? And then I just work from left to right. And again, when I'm done, it has to make sense. It has to have the same meaning. So 17, take away, so that's subtract, 4 multiplied by a number. And I use the letter N. And I'm going to use the letter N because anytime I see the word number, it starts with the letter N. So for me, that just makes me happy. You could use whatever letter you like. If your name is John, use the letter J. Using the letter S, though, isn't very good because sometimes it looks like the number 5 if you have bad handwriting. And that would be me, so I don't use the letter S. All right. When you're done, again, the expression has to mean the same as the original. 17 take away 4 multiplied by a number. There we go. Let's try it again. The quotient of 64 and 16 increased by a number. All right, the easy part is we had two numbers in there, 64, 16. Let's look at those phrases now. What about this one? Quotient. Yeah, quotient. Did you remember what that was? It's division. Okay, so we have division. We're going to divide 64 and 16. And our next phrase here is increased by. We're going up, so we're adding. Good. And what about this phrase? A number. We're going to do what with it? A variable. So the quotient. So we're going to divide 64 and 16. So that's 64 divided by 16. And then I think you told me to add some number. 64 divided by 16, then add a number. Now, today I'll let you use dot bar dot, but really in algebra we write it this way, 64 divided by 16, and then we're going to add a number. All right? It's okay if you wrote it this way, it's just fine, but we do like it this way better. And you did it. So, again, make sure it means the same thing, and I'm pretty sure we did. So now it's your turn to practice. I got 5 problems for you, so you can pause the video now so you don't have to listen to me for at least a couple of minutes. When you come back, the answers will appear on the right side of your screen. Welcome back to Here Are the Answers. Dun, 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 dun. Let's check to make sure they mean the same thing. 5 increased by 4 times a number. 8 less, twice a number. These less, if it had been less than, this would have been switched. So, those are always the tough ones. Less versus less than. Let's not get into it right now. If we want to get into it, just email me. We can get into it. Let me tell you, it's a little tricky. 3 times a number increased by 9. All right. The product of 4 and a number decreased by 7. Look at this. And a number decreased by 7. So the number has to be decreased by 7 before you can multiply by 4. That's where the parentheses are. So the number decreased by 7, and then it's a product of 4. That was tricky. A number repeated as a factor 3 times. So a number, a number, a number. And since it's a factor, it means multiplied. Okay, so those ones were pretty tough. And especially this one, a number, 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 that's the number to the 3rd power, whatever number that is. Let's go ahead and work on algebraic equation. An algebraic equation has an equal sign. We're doing the same exact process, but now when we're done, we'll have to solve it. So here we go. 2 times a number, increased by 5, hey, so far so good, right? Is 37. So let's look at the important things in here. Let's look at those specific phrases. I've got the phrase times. What are we going to do? We're going to multiply. What about increased by? That's right, add. Ooh, a new one. Do you remember where this one is? Is going to be equal. So 2 times a number. What are we going to put in for a number? N. So 2 times a number. Here we go. 2 times a number. Increased by, add. What are we increasing it by? 5 is, ding, 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 equals 37. Ta-da! Now, to get credit, you have to write this first. Now you have to use your awesome algebra skills and isolate your variable. You have to get n alone. How do we do that? Well, let's do order of operations backwards. So we have multiplying and we have adding, and the opposite of adding is to subtract. So let's go ahead and do the opposite of adding. We'll subtract 5 from both sides of the equal sign to keep our equation in balance. And 5 take away 5 is 0. So the 5's gone from this side of the equal sign. 37 take away 5 is 32. So I have 2 times some number in the world equals 32. So it's multiplying. And the order of operations backward state, we will do the opposite of multiplying by 2 to both sides of the equal sign. And the opposite of multiplying is to divide. So I'm going to do 2n divided by 2, 32 divided by 2. And what's great about 2n divided by 2 are those 2's divide out to 1. So I'm left with 1n. And 32 divided by 2 is 16. So 1n is 16. So pretty much 2 times 16 is 32. Increase by 5, and I add 5, and I get 37. Woohoo! We did it! Let's do it again, because that was a lot of fun. All right. We have 85 decreased by 3 times the sum of a number and 7 is 43. All right, let's look at those phrases here. Specific phrases. Decreased by. So we're going to do 85 and decreased by. What are we going to put right here? Subtraction. So I have 85 subtracting. Let's look at our next phrase. Times. 3 times. So I'm going to do 3 times something. So we're going to do 3 and we're going to multiply. What are we going to multiply by? The sum of a number and 7. And I put that all together because before I can multiply, I have to do the sum. Sum is the answer to an addition problem. What addition problem? The sum of a number. What I'm going to put in for a number, okay, variable, and 7. What am I adding? I'm finding the answer of adding some number n and 7. What are we going to put in for is? Equals 43. All right, so 85 decreased by, so take away 3 times, I put a parenthesis there for times, the sum, because I can't multiply it until I add and find the sum, which is the answer to an addition problem, n plus 7, parentheses, equals 43. Okay, so we get credit for writing it. What? Yeah, that one was a little tough. But that's okay because we can now solve it. We need to get n alone. And how can we do that? Order of operations backwards says I need to get rid of adding and subtracting first. So I need to start with any adding or subtracting. This is parentheses. Where's that? Last. So we have to get rid of this 85 first because it's 85 and it's positive. A lot of students will tell me, but it's takeaway. No, 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 no. That takeaway goes with the 3. That's takeaway 3 times this. But that 85 is a positive 85. And the opposite of a positive 85 is a takeaway 85 or a negative 85. And 85, that's positive. Takeaway 85 is 0, and that's what we wanted to do because we're going to go to the other side of the equal sign and do 43 takeaway 85. And yes, it is negative 42. And see, remember that sign goes with this 3. So negative 3 or take away 3, they stay together. And the sum of n plus 7 equals negative 42. So we took care of adding and subtracting. We're going backwards. So here we go. Multiplying and dividing. Remember how this is negative 3 times? Or it was take away 3 times? Well, we're going to call it negative 3 because the takeaway sign's still there. And the opposite of multiplying is we're going to divide this whole side by negative 3. Let's jump across the equal sign. And this negative 42 by negative 3. And our negative 3 divided by negative 3 leaves us with just n plus 7. And negative 42 divided by negative 3 and negative divided by negative is positive 14. Now I can drop my parentheses because I'm right down here. I did my multiplying and dividing. I don't have any exponents, parentheses. I just let them drop off because I have n plus 7. And now I can get rid of my adding 7. And the opposite of adding 7 is I subtract 7. And therefore 7 take away 7 is 0. So I have n equals 14 take away 7, which is 7. And we did it. We did the hard problem. Together we can do anything. And now alone you can do these. That's right, 4 problems. I will report back to you in just a moment with a page full of wonderful answers. All right, welcome back. I know that's the moment you've been waiting for. How did you do in practicing translating the following into algebraic equations and solving? Let's go through it. The sum of a negative 5, or the sum of negative 5 and a number, negative 5 and a number, is 3. And the opposite of a negative 5 is to add 5. So n equals 8. Did you like that one? That was good. The difference between 2 times a number, so what did difference mean? Subtract. The difference between 2 times a number and 4. So I have to subtract these two. 2n take away 4 is 8. So I add 4, divide by 2, and I get 6. All right, okay, we're doing it. 3 times a number added to 8 is 14. 3 times a number added to 8 is 14. So 3n plus 8 is 14, and then let's go backwards. Take away 8, divide by 3, n equals 2. Last one. I know, the tough one. How did you do? A number plus, oh look, here we are, a number plus the quotient of 56 and 7, 56 divided by 7, is 11, equals 11. And wasn't that cool? 56 divided by 7 is 8. So it was really like n plus 8 equals 11, and then you just subtract 8, n equals 3. How did you do? All right, probably like a rocket scientist. You're probably like acing it. So keep up the great work. If you have any questions, just drop me an email. We can chat. We'll make sure you work it out. Have a wonderful rest of the day, and happy translating from English to your wonderful language of math.